Let's give everyone some time to settle down and join the call. I think we're gonna have a pretty small group today because there's the BQ lecture, so I would appreciate it if you guys could give me any feedback or any sort of opinions you guys have about the course, and we'll take it into consideration for the next lesson and also the next series of workshops. So don't worry about it. Just if you have any questions or any feedback, just air it out. All right, let's just get started the workshop. So I hope you can hear me pretty well because, yeah. My name is Brian and I'm, again, your trainer for this workshop. And today we'll be covering digital forensics, which is basically the idea of getting information from data. So the topics we're covering is basically digital forensics, what metadata is, as well as some concepts like file polyglots, steganography, and some more advanced forensics applications as well. And every week I say this, but just be ethical and don't use the information here for any sort of legal activities. Now, this lesson should be a bit more fun for those of you who found the EXIF2 workshop interesting, because this one is a lot less about networking and all these networking concepts, and it'll be a lot more of a practical, local experience, I would say. So what is digital forensics? Well, it's just the idea of interpreting and uncovering any sort of electronic information. So imagine if you have a lot of data hiding somewhere. Digital forensics essentially is just a practice of figuring out where that data is. And the first exposure we had to forensics was in our first workshop when we used EXIF tool. So ideally what EXIF tool did was that it gave us metadata. And metadata is just data that describes other data. For example, if you have a cat, a picture of a cat, then the metadata will be stuff like what's the cat's, what's this picture's name, what's the size, who created this image, and also there's also a lot of different like data about it. So metadata is just data about data. And one of the most common forms of metadata for images, video, audio, and also on PDFs especially is EXIF. Sorry, I think it's just for images, my bad. Yeah. So EXIF is just a standard or a protocol that specifies a format for which different media stores their metadata, their metadata. And of course, since it's a standard, most devices can actually read EXIF, and that lets the devices actually figure out how to use this, how to present this image. And like I said, we actually used EXIF tool to figure out what the metadata for a certain image is. In this case, we had the garden challenge. For those of you who are working on the Pico CTF, we actually had garden.jpg, and you could find a flag using EXIF2 on the garden image, right? So I won't be covering this too much because we've already gone through this before. But if you want to learn more about EXIF2, essentially, you can read up about why EXIF2, sorry, you can read up about more. You can read up more about what EXIF2 can do, as well as the different types of use cases and real applications that EXIF2 has been used to solve a lot of different cases. And in this case, they actually use EXIF2 to figure out the location of an internet criminal, I'll say. So that's a pretty interesting read. So if you want to get to know more about Access Tools history, give that link a look. Sorry about that. But ultimately, Access Tools is a pretty simple concept. It's just reading the metadata of any image. Now, the more interesting thing we're going to be touching on is something called a file polyglot. And in traditional English, polyglot is just a polyglot as a person is just a person who can speak multiple languages, right? Therefore, a file polyglot is just a file that can be treated as multiple types of files. For example, you have your GIF or GIF images, you have your JPEGs, you have PNGs, you also have text files. But these files can actually be modified in a way that gives you access to, that gives other applications it lets other applications see it as a different file. For example, a GIF file is actually just a GIF or GIF, you can pronounce it that way, combined with a jar file. And if you open it as a GIF file, then it'll treat it as a GIF file. But it can also be opened as a valid jar file, which is a Java compiled library. So it's just a bunch of code. And one benefit of this is that it lets us exploit certain websites. For example, if a website lets you upload an image to the website, you could embed a jar code file in the image. And when the image is uploaded, the service wouldn't see anything wrong with it because it sees, oh, it looks like a proper image. But in actuality, there's a hidden code behind it. And if the website is vulnerable, you're able to inject code. And this is what you call a cross-site scripting attack. My bad. Any questions so far? All right. So ultimately, if you're going to talk about a file polyglot, it's just a file that can be treated as multiple files. And when we talk about a polyglot, of course, these files are special because they have to be set up in the right way. And there is a database of multiple file polyglots that you can actually use to test out your own services if you like to. Now, before we explain how polyglots work, we have to understand how applications actually determine a file type. And one of the most common ways is just by looking at the extension. So if you have .jpeg or .gif, kind of tells you that it's .jpeg or .gif, right? But of course, you're allowed to change these extensions. So if I have a text file, I can change it to .jpeg, and technically it's still a right file. It's just that I can't open it as a JPEG. It will say it's corrupted or it's broken. Because another thing that files have is called a file signature. And what a signature is it's essentially just a pattern within a file. For example, JPEGs always start with these 2 bytes and ends with FFD9. So if the JPEG doesn't start with these headers, it's one indication that it's a corrupted JPEG file. And similarly, PDFs always start with this sequence of bits as well. So if you want to figure out the file type of a file without any extensions, there are multiple ways you can do it. With Linux and Mac OS, you can actually use the file command. And the file command is just checking the entire file for all the different signatures, and it'll match it against a database. And based on what the match is, it'll figure out what the file actually represents. And on Windows, I don't think there's a file command, but you can use something called TRID, which is just a program that does the same thing as file. So I have a link here for you guys for, just copy the link. If you want to try it out on your own laptop, you can just download that file and try to figure out what kind of file it is. Essentially, I've removed the extension, so all you get is just the file name. But of course, like I said, files have signatures. Therefore, even without the extension, there are ways to figure out what kind of file this is. And it's a pretty simple exercise, so I'll give you guys about 3 minutes to download it and just try it out. And if you can't use file or if you can't use TRID, there should be online services as well. So if you just search it up, online file type checker. There should be one. So is everyone following so far? It should still be all right. So let's say I download this file. So I have this. I can see you guys coming in, so that's good. And as per usual, I'll just walk through it with you guys. So if you're on macOS or Ubuntu, you can use the file command. So let me just run file some data. So if I run this, the output I should expect is, I'll just give you guys some time to figure this out for yourself first. And if you guys are unfamiliar with this interface, it's just the command line. So for Windows users, use CMD, and for Mac users, use your terminal. For Mac users and Ubuntu users, you can use a file straight off the bat. But for Windows users, you have to be a bit more involved. You have to install TRID, but of course, you can always use an online service like this. Assuming I have the file, if I drag it in, you can do the same thing. So if I check the file type online, it should give me a zip. So it's a zip file. And if I look at here, yeah, that's pretty fast. That's just a zip file. So if anyone's actually figured out this part, I think I don't remember, but I think I hit a flag in this file. So if you guys can figure out what the flag is, just send it in chat and that'll be pretty cool. So it's a zip file. So does anyone will try to get the flag out? Yeah. That's pretty fast. Yeah. Essentially, I unzipped it and I got a flag. And there you go. CHF, you unzipped me. And this is a pretty simple exercise, but again, most CTFs can be pretty simple. So as long as you just try it out, you follow the clues, and given one piece of information, you take it and try something else, eventually you'll find a flag somehow. So last week we did DNS enumeration, which is basically going through the DNS service to figure out records, and we had the text record. That's basically one of the approaches you normally take with the DNS challenge. Last week we had a networking challenge. Essentially, what did we do? We did something in networking, right? Then last week we were essentially trying out CTS for the first time. And I mentioned that a lot of CTFs don't actually require a lot of programming knowledge, because as a hacker, we said again, it's not about your programming ability per se, but it's about how creative you can apply your knowledge. And of course, with more advanced topics, you have to get into programming. But with a lot of CTF challenges, it's as simple as this, and it's like solving a puzzle, right? Anyways, I hope you guys figured that out pretty nicely. I'll be moving on to the presentation. So while that example was pretty simple, I'm going to be talking about a more interesting well, yes, you can do that, because for some so for some operating systems, they actually use the extension file, the extension name, to figure out where or how to treat this file. So with Windows, I think if you change it to .zip, the files the file is automatically treated as a zip file and the program should open it appropriately. But of course, we only know that it's a zip file because we use the file command, which gives us which basically outputs the file type. Of course, if you're not on Windows or if you're not on Mac, and you're on your mobile phone, you can always use the online services. So I demonstrated one of the online services where you can just upload a file and the website will tell you what kind of file it is. Yes. So yes, if you want to extract the file, because you know there's a zip file, you can just .zip. You can add the .zip extension, and it'll give you back the file. So that's just one example of I guess hiding the file type. But with a polyglot, it's not just that one file has a certain type. It's not just that there's one type for the file, but the file can actually be treated as multiple types. So if you change the file extension as to let's say .gif, it will actually open as a GIF. Or if you change it to a .jar, it will actually be treated as a jar, but it's the exact same file. So the program will treat it accordingly based on which program you open it with. So the GIF file vulnerability is essentially hiding Java code within a GIF file. And how it worked is that because zip files actually represent one file, but they contain multiple files within, right? So what they do to separate the different files is they provide an offset. So let's say I have a safe file called safe.zip, and the file, if you open it as a stream of text, you get 0133, etc., etc. Now, if you take this file and you read the data, the metadata about the zip file, you actually see that they have information about where every file is. So it will say, oh, readme is at position 0. And the next file is description, which is at position 8. And so on and so forth, which explains basically which part of the data is which file. And that's how a zip file normally concatenates files into one file. But there is a vulnerability of zip files, or technically a feature of zip files, that you can actually specify non-zero offsets for the first file. So imagine if I say that the first file, the readme, is all the way in position 12. Now, when you do this, you're basically given 12 free spaces before the zip file actually starts. But the zip file also think that the first file is the very first file. So what GIFA does is that it takes the zip file, it modifies the metadata such that the files are moved back, and then it adds in this bunch of characters or this data. And this data is just the signature or the file headers for a GIF file. So when a website looks at this file, it'll read the first few bytes, 474946383761, and I think, oh, this is a valid GIF file. So I'll just put it up into my website and I'll just run it and try to present it on the browser. But of course, since the file is treated like a normal GIF and still contains Java code, what happens is that we can actually run the Java code from this image file, depending on the server. So I don't have a example website for you guys because I couldn't find one, and I couldn't set one up in the week leading up to this. But ultimately, all polyglot attacks work in the same way. So you just hide some code within another file. You upload the vulnerable file into web service, and you cause the web service to expose some sort of vulnerability. So if you go back to our cyber kill chain, you remember that we went through reconnaissance, which is looking for services that might be vulnerable. Then we talked about scanning, which is about being more active in looking for data about a target. And once we hit scanning, we actually dealt with weaponization, right? So weaponization was the idea of creating a weapon or a tool or some sort of vulnerable piece of data that you can use to deliver to your target for vulnerability. So in this hypothetical, let's say that I found a website through my reconnaissance that uses an outdated version of Java as the front end. Then I know that there might be a possibility that it's exposed to a GIFA vulnerability. So I scan the website and I figure out that, oh, it's actually running Java 1.6, which is a vulnerable version of Java. So now I know, okay, this website has a vulnerability. I'll start looking for a attack surface, for example, an upload link or any sort of part of the website that lets me upload an image. I'll find, and let's say I find one. Luckily, then I'll know that, okay, so this website is vulnerable to a GIFA attack, and there's a surface for me to upload my code. And this upload will be called your delivery. So I'll build my GIFA, and that's my weaponization. And then using that vulnerability, when I upload this file onto the website, that's my delivery. And that's how you perform a attack, conceptually at least, because I don't have an example. So if you guys find one, definitely post into the Padlet because that'll be really great. And I think it'd be pretty fun if you guys could help me out with the examples as well. But that's what we have for a file polyglot, and that's the conclusion we have for vulnerabilities that involve file polyglots. I think another interesting thing we have is something called steganography, which is essentially the idea of hiding information within information without being suspicious. So with cryptography, you take data and you transform it in a way that it's impossible for someone without a secret to uncover. So it's like locking a file. But the issue with cryptography is that people will know the file is locked. And when someone sees a locked file, it becomes a target of interest. Steganography, on the other hand, it's similar to cryptography, but the main point is that we want to make it unsuspicious. So steganography takes, for example, a text file and it hides it within another file. And in a good scenario, you wouldn't be able to find the text file unless you knew the exact way of extracting that file. For this, I actually have an example for you guys, and I have a workshop and hands-on, so look forward to that. And we'll be using something called StegHide, which is a steganography tool that hides information within images, video, I think audio files, and PDFs. I think this is the one, yeah. So what StegHide does is it does something called least significant bit steganography, which is essentially taking the least important information in a file and using that space to store data. And I linked a online tool for you to encode and decode to steganography, so StegHide images. So just use that if you guys want to like do any workshops with it. But I think what's more interesting is that we can figure out how StegHide actually works, and to learn how StegHide actually hides data within images, we need to think about how an image is actually represented in digital media. So an image is basically made up of multiple pixels, and every pixel has 3 colors or 3 channels: red, green, blue. Now, every pixel's channel has 8 bits. So for the red channel, there's 0 all the way to 255, which is 8 bits. And one pixel will essentially have 3 sets of 8 bits, which represents the R, G, and B, or in this case, the brightness of the red colors, blue colors, and green colors. So what StegHide does is that it takes the smallest bit in every single color and it uses that to hide data. So by changing the brightness of every pixel by one small fraction of a fraction, it can actually store useful information within an image. And to a human eye, when you look at an image with like a 0.1% change in its brightness, you wouldn't know the difference. So this is a pretty cool way of hiding information within images. And I have an illustration here to explain a bit more of how it actually does that. So let's say we have pixels on the image with all these values, and we want to hide this data in zeros and ones. We'll just take the data, we break it up, and we put it into every pixel one by one. So after hiding, like I said, the values barely change. But what we get is a way of storing data in an image. And of course, if you look at it this way, it's pretty simple to just run every image through a steganography tool to figure out if anything's actually being hidden by StegHide, which is why StegHide actually provides you with a password, and it lets you encrypt data before you actually put it into the image. So this way, when someone actually tries to run StegHide through every image you have and try to decode images from it, they'll just get random noise and they'll think it's just nothing. Right, so we have a file, and this file actually takes advantage of every single bit of information you guys have learned over the past 4 weeks. So there's a little bit of I have some hints there, but essentially you have to use some of your information from week 1, some from week 2, and some from this week. So if you guys find all the flags, if you guys find any flag, just put it into the chat, and that'll be pretty fun. So don't worry about it. It's a pretty small group, so it's not a lot of competition, right? So I have some hints, and if you guys need any help with the figuring out what the hints are, just put into the chat. So if you guys have any questions in the meantime, you can always ask me. I'll just leave you guys to it, yeah? Just download the file and try to figure out where all the flags are. And if you guys need any help, really just either private message me on Telegram, put into the chat, or if you're feeling ambitious, you can always turn on your microphone. Hey, that's one. Nice. So how do you get that one, Ginny? Ginny? Is it Ginny? Was it the all right, so yeah, so this one was the steganography one. So this flag was hidden with StegHide. That's a great one, yeah. We look cats and dogs. So essentially for that flag, we use the online decoder to find the information within StegHide. Now, there are still 2 more flags within this file. Yeah, that one was the was it the EXIF2 one? Well, then I gave the other flag away, right? So that one's strings. So essentially, yeah, that's strings, yeah. So that's 2 of the flags. There's still 1 more. And if you guys find it, just share. And even if you found it after Junyi and Hatanto, just feel free to share your methodology or what your process was to figure out the flags. Hey, Hatanto got the last one too. Yeah, so that's the EXIF2 one. So I gave some hints, but that's cheating, isn't it? Okay, so what Hatanto used was something called forensically. Yeah, this is a really common image tool. So what you can use forensically for is essentially it basically does all of the different possible ways of it basically runs through all the different methods of figuring out what's in a file and automates the process for you. So I gave hints because I treated them like separate challenges. But of course, you can just use forensically and it'll give you most of the flags. So let's say I take, oh, it doesn't let me take that. Huh, that's sad. Well, it's fine. Essentially, yeah. So Yihao asked if stack height is actually hiding it within the locations in the bits. And if you look at it from a high level perspective, essentially that's what it's doing. So it's taking the data, it's splitting it, and it's putting it into the file in strategic locations, and decoding is doing it in reverse. Yep, exactly. So it's taking the data and splitting it and putting the predetermined locations. And to undo it, it just looks at those same locations and it takes out the data. Yeah. And I mentioned this just now, but I think I should repeat it. Essentially, if the locations are predetermined and if everyone knows what stack height is, then if you don't have a parser on your stack height data, people can just run it through stack height and get the secret out of the image. So what stack height provides is a way of adding a parser to your data, such that when you encode the data into the image, you can actually hide the information. And the key is not necessarily a predetermined location. It's just that the key encrypts the data before it actually encodes it. So when you encrypt it and you put it into the image, it makes it a lot harder for people to find the data out of the image, because when you use stack height on the file, you look at the locations and it'll extract the data, but the data will look like nonsense. It'll look like random noise. So it'll look as if there's no data in the file itself. And with encryption, you can't actually decrypt it unless you have the secret key, or in this case, the password. So if you're a threat organization looking to find secrets, it's a lot easier to be guaranteed. You're guaranteed to know that there's something that's encrypted if you are given an encrypted file. But with steganography, let's say they extract some sort of data out of the image, it'll look like random noise, right? But the thing is, they won't even know if it's actually an encrypted file. So it's actually saving. It's basically not feasible for them to scan through all your data to find the steganography images, essentially. But as to the actual implementation of stack height, I think that definitely warrants a bit more investigation, whether the location within the image is determined based on the passphrase. But as far as I'm aware, it's not actually based on the passphrase. The passphrase just encrypts the data before it gets encoded into the image. And the location is always the smallest bit in the image, because you want to leave as minimal of a trace as possible. Like here, it's always put into the last bit of every channel. I hope that helps answer a little bit of the questions, because right, so you guys have found all the flags, and this is a pretty short demonstration. I hope that was fun for you guys, because that is a pretty fun setup for me, at least. Okay, so let me just walk through the different solutions for those of you who are curious. So I have other data. So the first tool is use access tool. And you run it, you look at all the flags, and you notice that over here, the artist is CHF, who are we? That's one flag. Then another flag is this. This is called a hex editor, so it's basically your hex data. And at the very bottom, you notice there's a CHF tag here. And to easily view it, you just use strings. So strings, like we said previously, it looks through the entire file and it finds any sort of text data it might find. So over here, it finds all this text, but we find CHF, there is more. That's another flag. And I don't have stack height on my Mac because it's a bit difficult to set up. So what I did is I actually used the decoder as well. Stack height decoder. There you go. Same one. Let me just take this, plop it in. There you go. And that's the last flag. Well, this is a question about how much, this is a question about what you mean by what data is, right? Because ultimately, if you don't really know where the predetermined locations are, you're basically sifting through a bunch of data in hopes of finding some sort of pattern, right? But I guess if I had to analogize it, it would be like having a code with your friend saying that, oh, I'm going to leave markers in this pile of sand. And I'll say that, oh, every piece of sand in a certain location is where the data is found from. But there's so many grains of sand in this bucket that if you didn't know where to look for, you could pick out any piece of goodness, that's a bad analogy. Well, let me think of a better way of putting it. For example, a storybook, right? Let's say you have a storybook and you have pages, chapters, and words. And if you tell a friend, I'm gonna mark every second word of every paragraph is code, then that's a sort of way of communicating with you and your friend. But if someone who has the book and not the code sees this, if they don't know to look at the second word of every paragraph, it becomes essentially no code, right? So ultimately, they could brute force it by going to every combination of every word in the book, but you come up with so much data that you can't really know if it's real data or fake data. So yeah, ultimately there's no way of, it's difficult to brute force a file if you don't know the pattern or the methodology used to encode the data. That's really long with the answer, I'm so sorry, but that's ultimately what I'm trying to say. I hope that answers the question though, Yihao. Because my explanation for it was pretty messy. All right, I'm glad I could answer that question with such a bad analogy. But okay, so for the last 20 minutes of the workshop, let's put it at 10 minutes. Essentially, just going to be talking about some more advanced forensics methodologies to give you an idea of what's possible. Now, we can't really cover these topics now because they take a lot of time to learn, I think. And within an hour, I don't really think you can cover all these things. But if you're interested, you can always approach me or approach the White Hat seniors. And we have a lot of seniors who are very into forensics who will be more than happy to help you guys learn forensics. So the first one is one of the most, I think, most well-known, something called reverse engineering. And it's just the idea of taking a compiled piece of data and try to figure out how the code is actually built. So reverse engineering is a process of deconstructing a black box system, in this case, the program, and figuring out how it works. And the reason why hackers and even like blue team and red team hackers want to do reverse engineering is because it lets you know how a program actually works. So for an attacker, when you know how it works, you can more easily figure out the vulnerabilities of this program. And for a defender, let's say someone injects malware into your software. If you can decode and reverse engineer a malware, you can essentially figure out why this malware is, how this malware actually hides itself, how it works, who made this, and stuff like that. And The reason why I can't really teach you guys reverse engineering now is because with reverse engineering, most tools, reverse engineering requires you to understand how to read and write assembly. And for the computer science students, if there are any among you, you'll be learning assembly next semester. But and you understand what I mean, like, but it's pretty hard to learn because it's very, yeah. Hartanto's my batchmate as well, so he actually learned assembly with me last year, and it was fun stuff. And yeah, he did a cybersecurity course as well. Yeah, reverse engineering takes a bit of practice and a lot of you have to know how to write assembly essentially. So I won't be covering this in this workshop, but if you're interested, learn assembly. Come to me, come to Hatanto, come to our seniors, and we're more than happy to help you guys learn it because it's fun. And we also have memory analysis. So memory analysis is essentially taking a snapshot of your RAM and going through the RAM and all the data to figure out any sort of sensitive information. Because when you have secrets, for example, an encrypted file on your laptop, to use the file, you actually have to decrypt it. Because you have to decrypt it before you can actually use it, right? And when you decrypt it, it's stored in memory. So let's say an attacker was able to capture a snapshot of your memory, or let's say you find a laptop. As a investigator, you find a laptop. You can actually take a snapshot of the memory, and you can analyze memory, going through it, and figure out any sort of data. And if you watch CSI or any sort of those detective crime shows, wait, is it recording? Yeah. So if you watch any of those shows, when they always analyze computers and stuff, they're basically analyzing the hard disk or the stored data, but they can also analyze the memory if they're lucky, and basically figure out any sort of data within the computer that has been processed and decrypted and available for programs to read. And again, I can't really cover memory analysis in this workshop because memory analysis requires a bit more understanding about OSs and how OSs actually structure the entire memory and hardware and stuff like that. So again, if you're interested in learning, there are tools you can use online to figure out, or like, I guess, script your way through memory analysis. And I think it's pretty worth learning, but I won't be covering in this workshop because I think it's a bit too much. So I have a few links to a few tools you can use for memory analysis and reverse engineering. And I think I should add something called DA. If you guys have any recommendations. So what IDA is just a tool that lets you decompile programs. That's essentially what it is. I just didn't add it in, but there, IDA. If you're interested, I'll add a link to it, to the download page for IDA. But what it does is it takes code and looks at a pattern, and it'll try to figure out how it was built by reverse engineering it, and it'll basically output you the rough assembly code that makes up the program. And if you have IDA Pro, I think it tries to translate that. It tries to translate the assembly into something like C, so it's a little bit more readable. But IDA Pro costs money as well. So if you have the funding or if you have a grant, get IDA Pro. And Binwalk is another program that works kind of like string, but in addition to finding string data, it actually finds other types of data. So Binwalk is a combination of string and file. So the file tool looks at the file signature of a file and tries to figure out the file type. But Binwalk goes through the entire file and tries to figure out if there's any hidden files within the file. So it'll find images, text, any sort of media, any sort of code hidden within an archive. And Binwalk's normally used for decompiling images. Okay. Images in this case, I mean disk images, like .iso files. So any sort of compiled stuff, you can use Binwalk to walk through it to figure out if there's any resource hidden within the ISO file. And volatility is just one of the most popular tools used for memory analysis. So volatility actually helps you figure out it basically lets you apply a set of pre-configured locations to look into the memory file to figure out where everything is. So it can say, that, okay, this memory file is captured from a Windows XP computer. Then volatility will do all the magic. It figure out, okay, so in this file, for Windows XP, program memory is stored over here. The OS is stored over here. And it'll basically figure out where the locations for all the different file types are. Volatility is great for memory analysis, and it's one of the most popular tools. And I have further resources on the side, basically giving you examples of what binwalk does, how to do steganography in a very ordered manner, as well as a cheat sheet for volatility, which is basically going through all the different commands you can use to figure out memory analysis packets. But these things are, of course, beyond the scope of this workshop. But if you're interested, give it a go. Self-learning is the best way of learning, right? And next lesson. Oh, this is a bit wrong, but unpreparedness. I'm sorry about that. Learning about hashing and how to crack passwords. So for this week, we covered stuff about forensics, decompiling stuff, analyzing data, metadata, file polyglots, as well as steganography. And I hope you guys had learned a little bit about forensics, but of course, forensics is a very big field, so it's a lot of advanced topics as well. So if you guys find the first part of the workshop interesting, I think you'll find digital forensics as a whole pretty fun. And I hope that motivates you to figure out and learn about more advanced digital forensics tools and concepts and practices. Next lesson, we'll be talking about hashing and passwords and how these things work, as well as how to break it in a way, how to crack passwords. And that's all I have for you guys. If you guys have any questions about this workshop or previous workshops, I guess we can spend about 10 minutes of the allocated time to just discuss it and figure out is there any recaps you guys want to go through or anything you guys want to learn in addition. So we have week 5. Oh, and before I forget, I'd just like to remind you guys that I'd like to tell you guys that we, as a society, we're planning something for recess week essentially, and hopefully we can give you guys some space to come to school and just, I guess, meet up and mingle with your peers. So just a heads up, we're trying to organize something for week 8, the recess week, and I'll hope to see you guys there just to get to know you guys better, I guess, because I haven't seen your faces yet, and I think it's a bit sad for you guys, I think, because you guys can't really meet your friends in school, right? So if you guys have anything planned for week 8, I hope you guys have anything planned for week 8. So just letting you guys know that we are setting up, we're trying to organize something for you guys. Any questions? Because that's all we have for this week. Do you guys? I'm gonna stop the recording for a bit.